So 10Cs, we have spent a couple of lessons looking at the fact radicals are just roots. We've worked with roots before, but now we're expanding our knowledge, and we're going to expand it another step today. So this particular unit is called roots and powers. That's what the textbook calls it, or radicals and powers. Well, there's a reason the two of them go together. We've talked radicals now, and radicals can be a square root, it could be a cubed root, it could be an eighth root, even though we wouldn't work with that very much. And powers, well, we reviewed this a little bit previous in the year, but a power, remember, is an exponent on a base. Any base that has an exponent. Well, the reason we call this unit roots and powers is radicals and powers are related. And we can get a power that looks kind of ugly because our powers now in this unit are going to have fractional exponents. Yeah, we've never worked with fractional exponents before. So we're going to have a to the 1/2. And we're going to have a maybe to the 4/3. But if you pay attention, this is another little tiny process in this unit that if you practice it and learn it, oh, does it simplify life immensely. So let's take a look. If we take a look at page 23, page 23 has this little question, the radical root 4 times root 4, and then it has the power 4 to the 1/2 times 4 to the 1/2. Okay, I've added this cube root one just to show that it's going to work. But let's take a look. Square root of 4, well, we should be able to figure out that that's 2. And the square root of 4 is 2. And if I go 2 times 2, I get an answer of 4. Well, if I do 4 to the 1/2, all right, I'm going to pull up my calculator, and I'm going to do 4 exponent 1/2 to see what my answer is. So if you recall, calculator, 4 is my base. This little arrow is going to be my exponent. And I want to punch in an exponent of a fraction. Remember to put fractions, we bracket it and use division. 1 divided by 2. So I end up with 4 exponent 1/2. Well, when I hit enter, it equals 2. So 4 to the 1/2 is equal to 2, which means 4 to the 1/2 is going to equal 2. Well, that's also equal to 4. But what I really want you to see here is that we have the same base, same radicand. Here I square rooted, here I did exponent 1/2. They mean the same thing, or they got us the same thing. So that's telling us that square rooting something is exactly the same as doing the exponent 1/2 of it. We see that. Square rooting a 4 and using 4 to the 1/2, both of them equaled 2. It did the same thing. Let's try another quick one here with the squares. If we did, let's pick a number that we know is not going to work nicely necessarily. If we did 7 to the 1/2, we're saying that the square root of 7 should be the same as 7 to the 1/2. Square rooting something should be the same as having it exponent 1/2. Well, let's check this out. 7 exponent 1/2 and square root of 7. What do we get for values? Well, let's square root 7 first. Square root of 7, 2.6457, blah, blah, blah. Well, let's do 7 to the 1/2. 7 raised to the exponent. To put in a fraction, I need brackets. 1 divided by 2. And 7 to the 1/2, 2.64575, blah, blah, blah. It's the exact same thing. So this is what we are going to focus on. The fact that Having an exponent of 1/2 is the exact same thing as square rooting a number. Now, I've added, like I said, this piece. Does it work for cube roots? Well, cube root of 27, what do we multiply 3 times? 3. Times cube root of 27 is 3. So cube root 27 is 3. That's important. Well, what's 27 to the 1/3? Let's check it out on our calculator. So 27 raised to the exponent in brackets, 1 divided by 3 gives us our exponent, our exponent of fractional 1/3. That equals 3. So 27 exponent 1/3 also equals 3. 27 1/3, cube root 27 is 3. 27 to the 1/3 is 3. So what does this tell us? This tells us that if I cube root something, that's the exact same thing as having that something with an exponent 1/3. That, whether you believe it or not yet, can really simplify some of our calculations. So let's quickly review what we just talked about. If I want to square root something, it's the same as having that radicand with the exponent 1/2. If I want to cube root something, it's the same as having that something to an exponent 1/3. Well, how does that become useful? We have a whole bunch of examples on page 23, and it says write each of the following in the different form and evaluate. Well, if I gave to you 16 exponent 1/2, you would have looked at that and said, exponent 1/2, how are we supposed to do that? Well, what do we know? Exponent 1/2 is the same as square rooting. So this is the same as just square rooting 16. And I'm really hoping you know the square root of 16. What do you multiply by itself to get 16? It's 4. So 16 to the 1/2 is 4. Not that bad. Square root of 36. Now, square root of 36, we know, or we should know, that equals 6, because that's what we multiply by itself to get 36. But what's the other form of this? What could I write just to practice the other form? Instead of square root 36, we know that square rooting is the same as saying you have an exponent 1/2. 36 exponent 1/2 also equals 6. Stop the video, try the ones that remain, and let's see what you come up with. If we finish here, 49 to the 1/2, exponent 1/2 looks miserable, but that just means we square root. Exponent 1/2, square root sign, square root of 49 is 7. This is way less ugly than having a 49 with an exponent 1/2. Same thing will work with cube roots. 64 exponent 1/3, a 1/3 exponent looks miserable, but exponent 1/3 is just cube rooting a number. And hopefully, as we've gotten into this unit, you can identify, what do you multiply 3 times to get 64? Well, that's 4. But this, hopefully, is much more manageable, because that looks ugly, but it's not that bad. Cube root of 125. What's another form of that? Well, keep our 125, but instead of a cube root, that's the same as an exponent 1/3. Now, I understand 1 is nicer to work with. What's the cube root of 125? What do we multiply 3 times? 5. We multiply 3 times to get the radicand of 125. 1,000 exponent 1/3. Again, fractional exponent's ugly, but an exponent 1/3 is just the same as cube rooting. What do we multiply 3 times to get 1,000? 10. So 1,000 exponent 1/3 is just 10. Fractional exponents look ugly. They're not that bad. Now, the last two at the bottom here are starred. They're at the bottom of the page in those brackets. I didn't do all of them, but these two, you're going to have to think a little bit. Why? Well, because decimals aren't as easy to work with, but being grade 10, you should be able to recognize what's another way to write 0.5. Well, 0.5 is the same as a half. So if I took 64 exponent 0.5, which looks ugly, let's make it a fraction, 64 to the half. That half tells us to square root, and a square root is just 8. So 64 exponent 0.5 looks horrible. Big base, decimal exponent. But if you break it into the little steps, none of this should require a calculator. 64 to the exponent 0.3 repeating. Well, a little more complicated, but the same idea. What's 0.3 repeating? You should know that that's the same as 1/3. That's a benchmark fraction. So we have 64 exponent 1/3, because decimal 3 repeating is just 1/3. So fractional exponent, it's 1/3. That tells us cube root 64. What do we multiply 3 times to get 64? We multiply 4. So radicals and powers are related. Here is the key. Without calculator, fractional exponents written as roots become manageable calculations if you know your basic facts. Now, just to finish this idea, it's not limited to just square roots and cube roots. Square root of a to the half. Cube root of a to the 1/3. Well, it doesn't start there. The pattern continues. If you have an exponent of 1/4, that's the same as the 4th root of a. 1/5 would be the 5th root of a. It's not a big stretch. 1 to the n, we're not sure what it is, so we could say the nth root of a. Whatever your denominator is, the denominator in the exponent is your index. And that's key. So 16 to the 1/4 is the 4th root of 16. What do you multiply 4 times to get 16? 2. This is still tricky, but that just looks ugly. So put it in a form that becomes manageable. 32 to the 1/5, well, that's the same as saying the 5th root of 32, which is 2. 81 to the 1/4, fractional exponent looks ugly, but that's just the same as the 4th root of 81. What do you multiply 4 times to get 81? A 3. So radicals and powers are related. Becomes relatively easy calculations even though they look tricky. So page 24. Here we go. Let's make it one step uglier. Well, now instead of just exponent 1/2, 1/3, 1/4, what if our numerator, that should be without a numerator of 1. My bad. Well, what does this tell us to do? What did we just write down on the previous screen? We just identified the denominator is your index. The denominator here, the square root of a, well, it's an assumed 2 there. That's our index. So that's what's going to help us. What's important here, again, an exponent that is a fraction. What's key? The denominator is the index of the radical. So 8 to the 2/3, we know we have the cube root of 8. There's your start. Your denominator is your index in your radical. But this too is what could be tricky, But take a look at this. If I just said, what if there is no denominator? What is that 2? That's just an exponent on our base. So we just need to take what we have, and our numerator is an exponent for the radical. And there you go. 8 exponent 2/3 means we want cube root of 8 exponent 2. Because this 8 to the 2/3, oh, that's like, are you kidding? That's impossible. But it's not. Because what's the cube root of 8? What do we multiply by itself 3 times to get 8? Oh, 2. And this exponent 2 just goes out front. We can do that without a calculator, no problem. Now, it is possible. Some people will write this. I won't. If you choose to, you can say that the exponent just goes on the radical. So you could have the cube root of 8 squared. You could, instead of saying it's your radical squared, you could say I'm going to square the radicand. I like this process because this is usually a nice, easy calculation, and then we just have to apply the exponent. Here, sometimes we can get big values. 8 squared, well, now we're getting to larger number. That's a 64. We can cube root 64 because this, if I do the exponent first, what do I multiply 3 times to get 64? Because that's what a cube root is. Oh, still the same thing. However, this can create some big numbers where this doesn't create as many. But that's the key. Exponent that's a fraction. Now we're where we need to be. Index and exponent. So let's take a look. Page 24. There's 3 questions, and I've added one on the double star. Give them a try, see if you can come up with answers, and then we'll talk. So here we go. 8 to the 4/3. What does this tell us? Well, it tells us we have a radical with a radicand of 8. 8 is our radicand. What's the denominator 3? The denominator is the index. So we know we're going to have the cube root of 8. And then I like to say I have that cube root of 8 and the 4, the numerator is the exponent. So there's our new radical. We want the cube root of 8 and then we want an exponent 4. What's the cube root of 8? What do we multiply 3 times to get 8? A 2 to the exponent 4. And that shouldn't be too complicated. 2 times 2 times 2 times 2 isn't 2. What am I putting? It's 16. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So 8 exponent 4/3 looks miserable, but you break it into steps. 64 to the 2/3. What does this tell us? This tells us we have a radical with a radicand of 64. Denominator 3 says we're going to cube root it, and the numerator of 2 says we have to square it afterwards. Here, what's the cube root of 64? What do we multiply 3 times to get 64? Well, that's 4. Make sure you apply the exponent. 4 squared is 16. Now, just to show you what I was talking about on the previous screen there, if I did 64 2/3, if I chose to go 64 and apply my squared here and then cube it, oops, sorry, that's not right. What am I writing? My bad. If I were to go 64 and square it, okay, I still have my index of 3, but if I want to apply the 2, the exponent 2, to my radicand, I would have to have 64 times 64. and then cube root whatever that answer is. That becomes pretty tricky, whereas if you look back here, applying the radical first, cube root, and then squaring, it's a little more manageable. So this 4 exponent 1.5, 4 exponent 1.5. Well, 1.5 isn't something we want, but what is 1.5 as a fraction? 1.5 is the same as 1.5. Well, if I turn 1.5 into an improper fraction, 2 times 1 is 2 plus 1, I get 3 halves. So a decimal can be converted to the fractional equivalent. And now that we have a fraction, well, now we can convert it. What do we have? Radical with the radicand of 4. Our index is 2. Do I even need to put an index of 2? I really don't, because square root means 2. If it's there, it's not wrong. I want to do that calculation, and then I want to apply the exponent 3. What's the square root of 4? It's a 2, and we want to cube that, which is 8. Looks miserable, I think. Oh, but the simplicity of it is pure genius. So our last one here, fraction forms. Fractions with fractions and all over the place. Still manageable. Don't think that this becomes complicated. We have a radical. 8 over 27. We want to cube root that, and then we want to square it. Well, remember, how do we work with roots that have fraction bases or fraction radicals? We just work with each one separate. So I just need to cube root the 8 and the 27 separate. Looks ugly, but again, think of the steps that we're learning. Practice them so you can recall them. What's the cube root of 8? Oh, that's 2. What's the cube root of 27? Oh, that's 3. So our cube root of 8/27 is just 2/3, and now we need to square it. Well, 2/3 times 2/3, because that's what squared tells, do it to itself. 2 times 2 is 4, 3 times 3 is 9. Again, this looks goofy. But you break it into steps, it's not that bad. So we are looking at how are powers and radicals related? How can we go back and forth between them? It's not that complicated, but it's one more little step to add to a whole bunch of steps we've done. Booklet, page 25, textbook. Not a lot of work for these, but things that require practice so they become ingrained in your brain. Have fun with it.